Welcome all. In this session of Python programming course, we are going to learn about Python data types. Before going into the session on Python data types, it is always better to get a clear understanding on what is actually the necessity for a data type in any language. Let's go with English, right? English is also a language, right? So when I speak English, actually I make use of some preliminary terms. I make use of alphabets. I group the alphabet, that is the characters, to a word, and I group a set of words to form a sentence. That what I speak. When I speak that particular sentence, another person is able to understand that particular sentence. This is how the English language goes on, right? So similarly, when I go for a programming language also, there requires a preliminary term that act as a input and output, right? I need some data which acts as an input or an output or a processing term during the program execution. So that data should have some name, should have a value, should have a type, everything, right? So what I have to do, I need to define clearly what is the name of my data I'm going to use. What is its value? How it is going to change? At each point of time in my program, what is the type of that value? Everything I need to have a clear understanding, right? So what is the name, right? If I give a name to a data in a programming language, I call it as a variable. Why I'm calling it as a variable is its value is going to change periodically or it may be constant during my program execution. If it is going to be changing, then I call it variable, or if it is going to be a constant, I call it as a constant variable, right? That is what the name I give technically for the name of the data in my program. Similarly, the value will have a type. For example, the value can be a number, a value can be a character, a value can be a word, anything. So I need to give what type of value it is so that it is easy for me to do the manipulation and processing in between the program. So that's what we are going to study, what actually Python language is actually providing with respect to its data type. How many data types it is going to support. These things we are going to see in this particular session. First comes the very basic numerical data types. So when I say numerical data type, I have two types of data type available in Python, and those are integer data type and floating point data type. So what is integer data type? This integer data type can store all the whole numbers, not only whole numbers, all the positive to negative numbers without any decimal points. That is from minus infinity to plus infinity, all the numbers except the decimal point numbers. Say for example, I'm having a number 1321, right? I'm having a number 1321, that is 1321. I call this number as an integer. Why? Because I don't have a decimal point here. Or I can say that the decimal point is at the last. It is fixed. It will not come inside. So these type of numbers, I call it as integers. And the second type of numbers which has decimal points, I call it as a floating point numbers, that is float. Why I'm saying it is a float is it will have the decimal point floating between the numbers. It may be 132.1 or 13.21. What will actually happen is it will have a point which will actually float between the digits of a number that determines its value. So we call those as decimal point numbers, which will have an integral part and a fractional part. Sometimes it will include a mantissa, right? Depending upon the representation we say. In programming language, we will have only the integral part and fractional part to be given more focus. So these are the two different numbers we have, that is integers and floating point numbers. Next comes a data type called a string data type, a very common thing for our communication also. which mean words. I say characters like a single letter character or a group of character which will form a string. Say for example, I say apple. Apple is a string, right? If you see here, I'm actually representing these in single quotes. You can either represent them in single quotes or double quotes. That is, it can be either represented in single quotes or you can represent them in double quotes, right? The characters or alphabets or words or strings. Everything you can represent in single quotes or double quotes, while numbers will be represented without any quotations. But string data types will be coming always with a quotation to have a difference. Now, what is the relation between the string and the numerical data type? Each string, if it is a single character, it will have a numerical value also. This numerical value is actually fixed by a person called as ASCII, that is American Standard Code for Information Interchange, ASCII value. So every single letter string will have something called as ASCII value. We'll have a detailed description on this when we go for small programs. So you just understand that each string, if it is a single character, will have an ASCII value to get it converted by itself to a number. For example, if I say capital A, when it is a string, it will have a numerical value as 65. So capital B will have a value 66. Capital C is 67 and so on, an incremental order. Similarly, if I say small a will have a value 98, small b will have 99 and so on. This is actually the ASCII values for every single letter string. So that every string can also be represented by a numerical item. Why? Because we always require or give more priority for numbers than any other data type. So we need a representation for numbers, even for characters. That's why we have this ASCII value. We also have ASCII value for many special symbols in strings, like your spaces, dollar symbol, hash symbol. For everything I have an ASCII value. You will see it in detail, right? So the basic data types are numerical integers and floating point numbers, and then string data type. Coming to the operations, what I can do with this data type is, the basic is addition operation. If I add two numbers, 3 plus 4, I'll get 7. If I say hello plus world, there are actually two string string data types, and these string data items cannot be added. Why? Because they are actually a group of characters. They cannot be represented as numbers. So what will actually happen is, they will get concatenated. That is, they will get blended or grouped to form a single word. Two different words, after applying on plus operation, it will form a single word. So hello plus world will become hello world. Next comes the floating point number plus integer addition. So 7.5 is a floating point number, 3 is an integer, together they form 10.5. This is with respect to addition of two different data items of different data types. In addition to addition, I also have subtraction operation, multiplication operation represented by star, and exponentiation. In Python, exponentiation operation is double star, star, star. If you want to perform A cap B, you can also put A cap B, that is also allowed, or you can also put A star star B. You can also put A star star B. So A star star B is actually used to denote exponentiation in Python language. That is A power B, right? That is actually A power B. We can also put. And we also have two different divisions available in Python. What are those? Are a normal division operation, another is floor division operation. So what is those differences is, let's suppose I'm going to divide 3 by 2, right? So what will be the result? 3 divided by 2 will give me 1.5. This type of result will be obtained when I use the division operator. When I use the floor division operator for the same inputs, 3 floor divide 2 will give me only the integer part, and the fractional part after the decimal point will not be displayed. Only the integer part will be obtained. The 0.5 result will not be displayed. This is what the difference between division operator and floor division operator. Next comes the modulus operator. What is modulus operator is, if I have two numbers 5 modulo 2, you should not have a confusion that it is a percentage operator. It is not percentage, right? If I have a number like 5 modulo 2, I'll get the remainder of this particular division. 2 on 2 will give me 4 with the remainder 1. And similarly, if I divide 7 modulo 3, if I divide 7 by 3, I split 3 into 2 times will be 6, and the remainder is again 1. So the modulo operator, that is the percentage symbol, will be giving me the remainder of two numbers. When dividing two numbers, the remainder will be received through the modulus operator. So, and small exercise on those operators, I have a equal to 10, b equal to 6, c equal to 3. And if I do print of a plus b minus c, so a plus b will give me 10 plus 6, 16, minus c is 3, which will give me 13. So the result will be 13. Similarly, if I say a divide b, that is 10 divided by 6 will give me 1.66667. Python will be giving more precise results because it is having more enough storage and the processing capacity. So it will give more precise results. So this much huge fractional part you will get. So it is saying that Python is more precise. And if I say a star b, that is 10 into 6 will give me the multiplication result as 60. And a floor divide, the double division, a floor divide b, that is 10 double divide 6 will give me the quotient value as 1. And 10 modulo 6 will give me the remainder value as 4. Right? This is with respect to the basic arithmetic operations in Python programming. That is addition, subtraction, multiplication, division, floor division, and modulus operation. We also have exponentiation. I think that is easily understood. Next comes the multiplication operation in strings. When you use the star operator in string, what actually happens is the star operator behaves somewhat differently. If you give two integers to star operator, it will do multiplication. But if you give a string data with an integer, star operator will do an operation called as repetition. That is, I am having a string hello star 3. So what is the operation going to take place is the data item, that is the string hello, will get repeated 3 times. Hello, hello, hello. That will be the output. And if I have a string hi, hi will be starred with 4, so that it will be repeated. It will be repeated 4 times. That is hi, 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 hi. I'll get that. Right. So this is actually called as repetition operation in Python programming. That will happen when I give a string with an integer, right? So if you give string star string, then that is an error. You should not do that. You should give a string and an integer to form repetition. Okay. Next comes the very good data type called as Boolean data type, which means that true or false. That is called Boolean data type, right? It is actually represented in the name like capital T RUE and capital F ALSE. That capital letter means a lot, right? So in Python, Boolean variables are defined by the true and false keywords. So the name keywords refers to the thing, right? Those words will have some special meaning. True means yes, it happens, one, like that. False means no, it doesn't happen, 0, and like that, right? So it will have some meaning. Those words are, we will call it as keywords of a programming language. They all come under the uh, data type called as bool data type. That is, we call it as Boolean data type. If you are given me any type or any variable, if I need to find what type it is, then I have a function called as type. I just say type of 4, it will give me class int. That is, it belongs to the class integers. If I say type of false, it will give me class bool. That is, it is belong to the class of Boolean data type. So that is what it is actually displaying. If you want to know the type of any data item, you can just say type of the particular value or a variable. Next comes some other operators like relational operators, which actually operates on top of those Boolean data type. Their outputs will be Boolean. Let's see how they are going to operate. Greater than operator. This greater than operator can be called as a comparison operator, which will check whether the two inputs given to it is actually being compared for the greater number. That is, if I say A greater than B, it will be written as either true or false. If A is greater, I can print it true, or if B is greater, I will print false. Similarly, if A greater than or equal to holds, we have A less than or equal to A less than B, and A double equal, right? If I say A equal B, it means that both A and B are going to be exactly same. Then I say A equal B. There is a difference actually. If I say A equal B, then I'm actually giving the value of B to A. If I say A equal B, I'm giving the value of B to A. That is actually A equals B. If I say A equal B, then I actually comparing A and B to check whether they are both having same values. That is A equal B. A equal B is transferring the content of B to A. That is, the value of B will pass to A, assignment. Here it is comparison, relational operator, finding the relation between A and B and checking that they both are equal or not. That is here rightly stated, RHS and LHS are equal or not. Similarly, I have A not equal to B to say whether that A, the value of A is not going to be equal to value of B, right? So I omit this is not the case. So A not equal to B. This will check whether the value of A is not equal to B or not. I am saying that it is not equal. So if it is really not equal, I'll get a value as true. If it is equal, I'll get the value as false. The opposite to A equal B. Right? Some exercises on that. Say, for example, I say print 2 greater than 4. 2 is actually not greater than 4. So I'll get the result false. Now I'm setting A equal to 5 and B equal to 10. And I say print A less than or equal to 5. Yes, A less than or equal to 5. A is actually equal to 5. So I can say true. My compiler will give me the output true. Next comes print B equal 10. If it is equal, what does it mean? Both LHS and RHS are having the same value. Yes, B is also 10 and RHS value is also 10. I'll get true as output. Next comes B equal 5. B is actually 10 and the RHS value is 5 and 10 is actually not equal to 5. So I'll get the output as false. Next, A not equal B. Yes, 5, A is 5 and B is 10. So 5 is not equal to 10. I'll get the result as true. Right? This is how the relational operators in Python will work. Greater than or equal to. Less than or equal to. Double equal, not equal to. These are the relational operators in Python programming. Next comes the logical operators. So logical operators are also binary operators, which binary operators in the sense they will take two inputs. which take two operands and returns a Boolean value again, that is true or false. There are actually two types in logical operator. One is called as AND operator, which says true only when both operators are true. And the other is OR, which says true at least when one is actually true. For example, if I have input 1 here and input 2 here, I have input 1 and input 2. If I say AND, right? If I say I1 and I2, that is, if I want to calculate I1 and I2, let's suppose I am denoting all the true, capital T R U E as T, and capital F A L S E, false, as F. If I say T and T, I1 and I2 will give me true. I1 and is the operator now. It is not a word, it is an operator. I1 and I2, both are actually true, I'll get a true. If I say I1 is true and I2 is false, then I'll get false, because if only both are true, I'll give true, otherwise I'll give false. Similarly, if I1 is false and I2 is true also, I'll go with false, because I need both I1 and I2 as true. If you say both I1 also false and I2 also false, then I'll say the entire term goes false, because both the things should be true. If I say I1 or I2, what is the next operator is OR operator. If I say I1 or I2, that is the next case, which will accept and give my output as true if any one is actually true. I1 is also true here, I2 is also true here, so I'll get true here. Here I1 is true and I2 is false, so OR operator will return true if either one of the operand is actually true. I1 is true, so I'll get a true here. Here I2 is true, so at least one is true, I'll give a true. Here both I1 is also false, I2 is also false, so I'll return false as output. So this is with respect to AND OR logical operators. So come here with an example. We have 1 greater than 2, which will be evaluated to false, and 1 equal 1, which will be evaluated to true. We know that false and true. See here, false and true will result in false. So I'll print FALSE, capital F, false. Next comes 2 equal 2, which is actually true, and or sorry, here the operator is OR. 3 less than 2. This is 2 less than 2 is actually true. Or 3 less than 2 is actually false. 3 is actually greater than 2. So T or F will return me T. R will accept at least one is actually true. It will give that output as true. Next, 2 greater than or equal to 2. Yes, 2 is equal to 2. 3 is greater than 2. Yes, 3 is greater than 2. True. True and true. It will give me true. Both are true, so the result will be true. Next, directly true or false. R will accept and give the output as true at least if one of the operand is true. Yes, the operand 1 is true. I'll get the output as true. Right? These are actually with respect to the logical operators in Python programming. I have two operators. One is AND, which will give the result Boolean true if both the operands are true. And I have another operator called as OR, which will return the output as true if at least one of the operand is actually true. Next comes conversion of data types. How can I do the data type conversion? Initially, we said that we don't declare the data types. Automatically, the data types are understood. I just say A equal to 123. My Python is intelligent to understand that 123 is an integer. Next, I say B is equal to 10.5. Python will automatically understood B is a floating point data type. It will automatically understand. C is equal to 5. Python will understand that C is an integer. Automatically, it will recognize. Similarly, if I want to convert any data type to any other data type, what I can do is just to call the particular data type. I say str of a. I say str of a. A is actually 123. If I say str of a, this 123 will become 123 in single quote or double quote. Single quote or double quote both means same. So what actually happens, I'm actually converting a number to a string. So string, if it becomes string, plus operator will now change from addition operation to concatenation operation. So it becomes 123 plus hello, that is 123 hello. Similarly, if I want to convert 10.5 to integer, I just call int of b. Now the fractional portion 0.5 will be disappeared. I'll get the value 10. Similarly, if I want to convert 5 to floating point, just to say float of c, it will become 5.0, that is the fractional part will be displayed with a point. If I want to display the type, just to convert a into a string and then use the type function, you will get class str, which is evidence that a is being converted from integer to string, right? In addition to these manual conversions, if you do any operations on a particular variable, the data type will automatically get changed. For example, if I have a equal to 123, c is equal to 5. A is also an integer, c is also an integer. Now if I say a equal a divide c, a equal a divide c. So what will happen? I'm actually dividing 123 by 5. 123 by 5 I'm doing. So what will happen? A will get the result as 123 by 5 will give me 5 into 2 10 and 5 into 4 20.6. Now A is becoming 24.6, which is a floating point data item. Now the data type of A will automatically get updated from integer to floating point implicitly. No manual conversion happened. Python will automatically do that conversion. Hence, Python is very widely used because specifying the data type is during the different lines of the code is actually a very tough task when you do big programmings, which actually C, C++, Java will actually do. We need to specify the data type, but in Python it is automatically updated. That's what the power of Python. These are actually with respect to the Python data types. We have seen the primitive data types like numbers, which has integers and floating point. Then we have seen the string data type. Next, we saw the basic operations like addition, subtraction, multiplication, division, floor division, exponentiation, modulus operation. Then we came from binary operators to logical binary operators, relational binary operators. We have seen for logical and relational operators, the result is Boolean data type, which is actually true and false. So then next we see how to manually convert from one data type to another data type. Next we have seen how data types will be automatically updated by Python based on the operations performed on those data. So these are actually with respect to the basic data types. Hope you are very much clear on it, and thank you.